All right, good morning, everybody. Welcome to CNET58. This is week 14. So we have this week and next week, and then the week of June 7th is our finals week. So I'll talk more about that, the finals week stuff next week, but basically it'll be a final exam and then a lab final that you'll have until Sunday night to finish. Just kind of similar to what we did with the midterm and the lab midterm. All right. This week, we're going to take a look at a couple of topics that are not necessarily major issues, but they're good to know about. So we're going to look at what is System Center and Microsoft System Center, and then also we'll talk about backing up in a virtual environment, which is very important. And then this week's lab, there is, and this should be published, yeah. So we're going to work with shared storage in our Hyper-V environment. So we're going to create an iSCSI target and use the initiator on Hyper-V to connect to it. Then we're going to create an NFS, a network file share server, and then connect to it using the NFS client in Hyper-V as well. All right, so let me go back here. And then I did create a video of this week's lab. So I did this yesterday. I went through and I did the step-by-step for the video. A lot of students have commented to me personally, via email or message, that they really appreciate those videos, because sometimes the instructions, although everything is there, kind of how do you get there? How do you get started? Where do you go exactly to do those things? The video shows you that. So, I know there's all kinds of different learning modalities, right? Some of us like to see it, some of us like to hear it, some of us like to do it. So in this class, even though it's online, I've really wanted to make an effort to show you it, have you do it, and then talk about it all at the same time. So hopefully that helps you get going on this week's lab. All right, so let me bring up my PowerPoint. Are there any questions or comments on last week's lab or where we're at kind of in the course? Anybody have any concerns or any input you'd like to share? No? Okay, that's fine. I just wanted to give you an opportunity to do that. All right, so I'm going to share my PowerPoint here. Hold on, I don't think I'm sharing it the wrong way. Let me share my screen. Yeah, Frankie wrote in the chat, and no comments, but you can't believe that we're almost done. I totally agree. This whole pandemic and online learning and teaching it's been a kind of a weird dichotomy for me. On one hand, it seems like it's taken forever, right? Like, God, it's been forever since we've seen each other and been in the classroom together. And then on the other hand, it seems like the time has gone by really fast. Like the semesters have really flown by. I mean, it's been just over a year since this all started. So, I mean, since we started teaching online was a little over a year and a half, almost a year and a quarter ago. So let me share my screen again. That's the one I want to share. And then there. So can you see my screen over there, the PowerPoint? Hopefully you can. All right, so with our Hyper-V. And today's lecture, if you remember when we talked about some of the products in vSphere's conglomeration of tools, and we said, we're really only using ESXi, but there's a lot more out there. This is the similar lecture with Hyper-V. So Hyper-V is part of the System Center Virtual Machine Manager. So Microsoft has a product line called the System Center. So the System Center includes all of these areas. And what was that game where it looked like this? Simon, remember the game Simon? Some of you probably don't remember that. You're probably way too young, but there's a little game that would light up beep, 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 right? And it looked a lot like this image here. But the System Center Virtual Machine Manager is this piece of the pie down here, which is part of the System Center app control. And Windows Azure is part of this. And this is how Microsoft intends a larger institution or a larger IT shop to manage their virtual machines. Because the way we have it set up is we have 27 separate servers, all of them with Hyper-V installed on them. All of them inside of Hyper-V have their own virtual machines. And each one of you is managing your own server. Now, in the business world, you will probably be the manager of multiple Hyper-V environments, right? There could be, 15 different servers that have, 10 to 20 virtual machines on each server, and you will manage all of those. So you're not going to remote desktop into server 1, take a look at it, then get out, go to server 2, right? There's tools that scale up that make this easier. And in Microsoft terms, that overarching tool is known as the System Center, and the tool specific in System Center to the virtual machines is the System Center Virtual Machine Manager. Okay, so this is one of those topics that really, if you work in a Windows server environment, you're going to see this. Unfortunately, in our class and with the material that I feel is more important, we really don't have a chance to get to this. So I want to cover at least in lecture so you can, when you get hired on somewhere, you'll go, yeah, I remember hearing about that. We discussed that, but we really didn't do anything hands-on there. All right. Now, one of the misconceptions about Hyper-V is that it's kind of a standalone, fully contained product. And that's not necessarily true. And we can get that feeling because it's so easy to turn it on and use it with just your basic server install. So on the surface, it seems like everything you need is there to deploy and manage virtual machines. And that is true. That is a true statement on a small-ish scale. It's when we get multiple Hyper-V servers and we want to manage the virtual machines holistically on those multiple servers, that's where Hyper-V's management capabilities become very limited. Okay, so even small IT shops will come to the realization that a single Hyper-V host is not sufficient for their growing virtualization deployment needs. So a single host machine can quickly become the single point of failure, right? And we've used that term over and over and over in this course. And when we design our environments, we always want to look and say, where is a potential single point of failure, and what can we do to mitigate that? What can we do to minimize the negative impact that would have on our environment? Okay. Now, clustering and fault tolerance are also needed to prevent those single point of failures as well. Other than just design, we should take a look at clustering and fault tolerance, right? Now, what is missing from that scenario is the ability to manage the infrastructure that can grow and shrink based on our needs. So that scalability factor is missing. Now, to the rescue, right? Just as we, paint this bleak scenario of our, we're on the edge of the cliff and we have nowhere to go, but, death is impending. Out of the blues, rides in on, the horse is our savior, our rescuer system center. So system center virtual machine manager comes in. Now, VMM gives you a consolidated view of your virtual machines across all your host server. And System Center works not only with Hyper-V, but also with VMware servers and Citrix as well. And this is an area that Microsoft has done their, whoever designed this, they did their homework and they said, if we can manage not only our server environments, but also VMware's and Citrix, why would anybody purchase vSphere when all they need is ESXi, and then we can manage it from our system center? Now, let me back up just a few steps here. System Center is a paid for service. It's not something that you download for free and use. You have to purchase it from Microsoft through their licensing channels. You have to go and you have to decide. If we go back to our little pie here, you have to, each one of these is an add-on. So you purchase each one of them, then you can build the whole thing if you want to. And they're relatively expensive, $7,000 to $10,000 for the System Center Virtual Machine Manager. Okay, but it can corral and let you work with all of your virtual environments, not just Microsoft. Okay, so that's a strong selling point there. Now, in an enterprise virtualization environment, it will not be uncommon to have several, if not more, Hyper-V hosts that you will have to manage. So System Center Virtual Machine Manager allows the administrator to manage multiple Hyper-V hosts from one consolidated management platform. So one of the key parts to this, and I'm gonna show a video here in just a little bit. Let me cue this up. All right, so we'll come back to that in just a second. But when the Virtual Machine Manager was released as an independent product, so this came out first because Hyper-V got very popular, and the VMM was released. It was designed only for Hyper-V, and then shortly after that, they added in support for VMware and Citrix's Zen server. So they got caught up with everybody and what they need there. Okay. Now, like most Microsoft server products, it's designed to be modular. So that means it can plug into other systems and communicate across them. So whenever you hear terms that like where they work together, they're modular, that almost always implies that there is a shared backend database somewhere, right? In IT, that's the only way those things actually work is, behind the scenes, when you pull back the curtains on the Wizard of Oz, that's what you're going to find is a database. Okay. And when you have a database, that's where you're going to also find shared storage. And that's why today is where we're going to pick up our concepts that we talked about previously, and I'm talking about again now with the iSCSI and the NFS sharing. So we'll add that to our environment this morning. Okay. Now there are a number of different components that you need to be aware of prior to installation. So the virtual machine manager has 5 major components, and we'll walk through these here in just a second, but I want to show a shortish video on how to get this installed. So again, we're not going to do this in a lab, but I do want you to at least be aware of this. Okay, so that's why we're going to show us here. Hopefully you can hear that. It seems pretty low.
Welcome back to another video. In this video today, I'm going to show you how to set up Microsoft System Center Virtual Machine Manager. So let's cover the 4 major areas that we're going to have to cover in this video. The first is going to be that we need to install Microsoft.NET 3.5.1. That's the first thing, and I'm going to show you a couple of hurdles that we're going to get past. The second thing that we're going to do is install Microsoft Assessment and Deployment Kit, the Windows ADK. And I'm going to cover the steps that we need to install for that. The third is installing Microsoft SQL Server, which comes with System Center Virtual Machine Manager. And then we're actually going to install Microsoft System Center Virtual Machine Manager. So let's go ahead and begin. Now, the first thing that I want to point out is that we're on a domain controller. I'm installing it right on the only machine that I have right now, which is a domain controller. Another thing that I want to point out is that I'm going to need some memory for this. Now, I set my VM to about 4 gig. The more the better, but from what I've seen as far as memory usage in a lab setting, 4 is as much as you'll ever need. In production, we can talk about that in another video. So let's go ahead and we'll go ahead and install the .NET framework. Now, here's the thing: if I go ahead and I install the .NET framework from Server Manager, it's going to fail. And I'll just show you where you would do that, but it is going to fail. So normally we'd go and we'd actually enable it right here. That will fail. I'm not sure why. It's probably because it's been deprecated and Microsoft wants you to install .NET 4. So what we're going to do is we're going to start up a command prompt. I'm going to make that a little bit bigger so that you can see it. Now, the first thing that we're going to have to check is to make sure that we have the media mounted. So I do have the actual Windows Server media mounted. Next thing we're going to have to check is where it's actually mounted, what drive letter. So my media is on D. And we're going to go ahead and use the dism command. Now, I'm going to say dism. We want to modify an online image, this image. We want to enable feature. The feature name is NetFX3. We then want to point it to the source. The source is going to be the D drive, sources, and it's SXS. That stands for side-by-side install. Now we want to install all of the feature and we want to limit access. Limiting access means it's not going to try and go out to Windows Update. So we'll go ahead and enter this. And the operation completed successfully. So we now have .NET 3.5.1 installed. I'm just going to push this out of the way. We're actually not going to need it again. The next thing I want to do is I want to create an account for our SQL install. So I'm going to go to Active Directory Users and Computers, open up my Contoso, write in Users. I'm going to create a brand new user, and I'm going to call this user SCVMM admin, and I'm going to name him SCVMM admin. Give them a nice strong password of capital P, lowercase a, SSWORD, 20 and the bang sign or the exclamation point. And I'm going to tell it not to change its password. Next login, user cannot change password, and password never expires. I'm going to go back into this account, and I'm just going to give them a description of, of SCVMM admin, and I want to make him a member of the domain admins group. Now, if we were doing this for real, we'd probably want to either heighten his access or limit his access, but we're just going to give him domain access, or domain admins rather, for this video. Now that we got that out of the way, we've got to go ahead and mount our Windows ADK media. Now, here's the thing. You're going to say, well, it doesn't really come in as media. You download it. Well, this VM really doesn't have any internet access. I never use internet access in my VMs. So what I did was I installed it on my tech computer. I actually told it to only download it, and then I actually put it into an ISO so that I can get it into this VM. So I'm going to go ahead and mount that media right now. And I'm just going to cheat. I'm going to wait until it pops up here and hit that folder. And I'm going to start the ADK setup. Of course, I'll accept the license agreement. Now, out of the ADK, the only things that we're going to need are the deployment tools and the Windows pre-installation environment, or Windows PE. I'm going to uncheck everything else. And yes, I'm unchecking Microsoft SQL Server Express. There's a good reason for that, and I'll explain it here a little bit. We'll go ahead and install. Okay, and we've successfully installed the Windows ADK. Now that we're past the second step, let's go ahead and mount our media for SQL Server.
Grammarly does more than catch errors. With Grammarly, you can find really...
Sorry about that commercial.
Now, when you purchase, and I did say purchase System Center VMM, of course you can use it as a trial, but when you purchase it, it will actually come as a bundle. It will come with the SQL Server license, and this license is only for use with Microsoft System Center VMM. So it's full SQL, but it's only to be used for System Center VMM or System Center Configuration Manager or Operations Manager or whatever product that you purchase. So we're going to actually install the full version of Microsoft SQL. We're going to go to Installation, New SQL Standalone, because we don't have any existing yet. And we just ran through the setup support rule, and all 8 passed, meaning .NET's installed and everything we need to continue. Now that we have the this portion set up, we're going to go ahead and click Next. We're going to accept the license terms. Now it said that SQL Server can't reach update services, and that is correct. As I told you, I do not have internet access on this server. So we're just going to click Next. However, it is important that after you install, not so much for a lab, but in production, that you update SQL Server. There's a lot of bugs, there's a lot of security exploits, And I can't stress this enough, but in a lab, in a vacuum, we're just going to go ahead and continue. Okay, and it ran a second setup support rule, and it shows that everything's pretty consistent. We are on a domain controller. It identified that. .NET application security is not set up, and the Windows firewall is on. And we're fine. We're just going to click next. We're going to set up SQL Server, do a feature install. And what we'll want to choose is the database engine. We'll want full text and semantic extraction for search. And we'll want reporting services. So we just need these three. We can always add features later, but we're going to just use these three for now. And we're cleared to install those. There's no warnings or failed. Now, instance configuration, we're going to leave it with the default instance. The default instance ID, well, everything's going to share port 1433 TCP. So what you can have is actually multiple instances of a database sharing the same port. And we're going to install to this directory right here. Now, if this was a production setup, we'd probably want to change that, and we'd want to put the databases and the transaction logs in separate directories. It's a little out of the scope of this video, and you can always move it later. So we'll go ahead and just click next. It found required space, so we'll just go ahead and continue. We want to leave all the services as is. We'll just continue. Now, SQL Server can run in two different modes, authentication modes that is. Windows authentication and mixed mode. Mixed mode is, well, SQL authentication is where there is an SA account or a set of accounts inside of SQL. Now we set up that service account, and that's the one that we're going to use. So we're going to go ahead and add SCVMM. And we'll just continue. Now we're going to install and configure on the reporting services. Everything passed, no failed, no warnings, nothing skipped. And at this point, we're ready to install. Now, this is a pretty lengthy process because it actually has to start up the services, and it's going to wait for the service to actually install or rather run. So there's a lot of waits in here. Now I'm going to speed this up pretty quick. And it looks like the SQL Server setup is finished. Everything's green. So we'll go ahead and close that. And I'm just going to close that out. And we've completed the third step. Now the fourth step is actually installing System Center VMM. So I'm going to go ahead and again mount the media. And we'll go ahead and run setup. And we want to install. Now we have two features that we're going to need to install. You'll notice when I check Virtual Machine Management Server, the console will automatically be checked. We could actually install the console just by itself, but we're going to install both, of course. We'll click next. We'll just set up some product information here, registration information. This is going to be Kintoso, user of Kintoso. And we can actually hit next here because this product will run in evaluation mode and give us a 30-day trial. So we'll go ahead and read the license agreement, check that we agree to it. We're not going to join the Customer Experience Improvement Program or CEIP. Now, as I said, if this was a production environment, we'd want to turn on updates. This is a lab environment, so we're just going to turn them off. We're going to keep the default location for installation. And we now have to set up the database. Now, the database was installed on server 1, as you see here. The port is 1433. And the credentials I'm going to use are going to be kintoso.com/scvmm, which VMM admin. And the password, of course, is going to be capital P, lowercase ASSWORD 20, and then the bang sign or exclamation point. We're going to choose the default instance. And if at this point you didn't have a username and password that matched, you'd actually get an error here. Now we're going to set up a brand new database and we're going to click next. Now the domain account that we're going to use to actually run the VMM service account as is going to be the same one, which is VMM admin or SCVMM admin. And we're going to put the password in. And we could also use something called distributed key management. For this lab, I'm just going to skip that. I urge you to read it, but for the lab, we really don't need that at this point. Going to keep all of the default communication ports. If we had a library or VMM library where we keep CAD files and installs and ISOs and VHDs, we could specify that now. But since this is a brand new install, we're just going to create a brand new Microsoft System Center VMM library. We'll go ahead and actually do the install. And we've successfully completed the install of SCVMM. So I'm just going to uncheck both of these. And I'm going to click close. And I'm going to show you the manual way of opening up the console. Let's close out of this as well. And right up here, you'll notice Virtual Machine Manager Console. If we double click that, it will actually start up Microsoft System Center Virtual Machine Manager. We're going to connect to the local host on port 8100. If we were installing the console on another machine like a tech computer, we would put in the server name here of server1.kintoso.com, and we can specify credentials. I'm just going to go ahead and connect with the current credentials of the domain admin. And we now have a fully functional Microsoft System Center Virtual Machine Manager, all ready to basically create virtual machines. But we need Hyper-V hosts first. That's why I set all of this up on one server. And we can set up our storage. We can configure our fabric, which are our servers, our networking, and our storage. Most importantly, any kind of virtualization platform, I always say it comes down to compute, networking, and storage. There's our library, which when we set this up, we basically had a shared created for us on server 1. I'm going in through the network to show you what that looks like. Right there, there's our Microsoft System Center VMM library, our VHDs, our application frameworks. This is jobs of what is actually running when you go ahead and tell a VM to get created. This is a service log, and it tells you where it's at in its job, as well as history, and then a multitude of settings to set this up. So I hope you had learned something. I hope you learned a little more about the installation of Microsoft System Center VMM. You realize it's not as complicated as it pretends to be, because there's very little on this topic. By all means, there's some free books out there on Microsoft's site. I'll put them down in the comment section below. If you have any questions or comments on this video, please leave them on Facebook, Google+, or Twitter, or in the comment section below. Subscribe to my channel, and as always, I thank you for watching.
All right, so that was the install, the configuration and the installation of System Center VMM. So again, that's good to know, to at least have seen that one time. There will be a day where you will work in an environment and you'll have to deal with that. You'll work with that. So let's continue with what are the 5 major components. So first, there's the management server, the console, which are the 2 things that he installed, and then the self-service portal, the VMM database, and then the library, which he alluded to that as well. So the management server is really the brain of the operations, right? The brain of the architecture. And it's this management server that connects to your hypervisor host and communicates to Hyper-V from VMM. So when you say create a new virtual machine and give it these attributes, disk and memory and processor, name, network, all those kind of things that we do, VMM just tells Hyper-V how to do that. So it also provides, it talks to providers of computer resources such as networking, load balancing, storage, and it will use the APIs, which is the application programming interfaces, by the external vendors to communicate, right? And this is a really big skill set for IT workers to understand, is how do you get one system to talk to another system, right? It's all about integration, right? With you probably heard the term, the Internet of Things. Well, how do we get all these different things to communicate, right? There has to be a way to do that. And the way it's done is with those application programming interface. So understanding some basic programming skills is going to help you in IT, okay? So the management server directly reads from and writes to its database. So all the information of all your Hyper-V hosts and all the VMs that you create on those hosts and all the networks that you create and have on your Hyper-V hosts and all the storage and all the memory and all that stuff is all stored in a transactional database, which the default one that's used is SQL, right? Microsoft SQL Server. So if we were to say, what are some of the big products that Microsoft is most recognized for? First and foremost would be last week's Exchange Server. Exchange Server is probably their #1 selling product line. Now with it in the cloud, it looks a little different, but it's still Exchange Server. And then right behind that would be SQL Server. So it's a very, very popular revenue product for the Microsoft Corporation. Okay, so when a virtual machine creation task is given to a hypervisor host that's registered with VMM, VMM talks directly to the management interface and passes all the instructions. Then it will keep track of the status and report back what's running. So it'll give you kind of a window that will show you what jobs are running. Because in this environment, now, when we do a server, like today, we're going to work with 2 different servers, one in CentOS and one in Windows Server. And we're going to create those using our differencing disks, right? The child-parent relationship that we've been using throughout. But in a production environment, you're probably not going to do it that way. So we would tell, and if we're using VMM, we're probably have multiple Hyper-V hosts and a multitude of virtual machines. So instead of saying, let's create one server and one client, we're probably talking about, let's create 100 servers and 500 clients, right? It's a much bigger operation. So we'll send all those jobs or all those tasks through VMM management server to the host, and then we'll get updates and we can see where those jobs are, because that's going to take some time. Okay, so that's where VMM gives us that overview capability of the entirety of our environment. All right. Now, the System Center Virtual Machine Management Console can be installed on the same server where the management role is installed, like we saw in the video, or it can be installed on any other member server. And this becomes handy so that we can install it on, say, a VM on our local machine, and we can open that, and then we can manage all of our environment. So it gives us a great deal of flexibility for managing everything remotely. So even in in our virtual environments of today, right, the work from home initiatives, we could still log in from home to our VMM console that would connect to our VMM server that would communicate with all of our Hyper-V hosts and all the VMs and all the networks, all the resources on our virtual environment, both Windows and VMware and Citrix, right? So super powerful. We can also perform a lot of these tasks either from the console application or from a PowerShell. So once we have the connectivity, we can write our PowerShell scripts and launch all this stuff just as easily. Now, you've probably heard me say that one of the goals for every IT director and IT manager I ever met, one of their main kind of life goals, their bucket list, is they want to be able to do their job sitting in a beach chair with an umbrella over them on a beach in Hawaii or wherever your favorite beach location is, and with just from their phone or tablet, be able to run their entire operation, right? And I had one student asked me one year, he said, Mr. Miller, are all IT directors really lazy? And I said, no, we're not lazy. We're just super efficient. We want to, if we can build it and if we can do it that way, why not? Right? Now, the amount of work to get to that point so that you're just sitting in your chair may have taken you 20 years to build up that environment. But once you do, I think you deserve the reward of, just chilling, listening to the ocean coming in and out and the cool breeze, and, have a little pineapple juice and relax with your family or your wife, and just enjoy life, right? All while you're working and making a good salary. So that's kind of the goal. So the VMM allows us to do that. There's also a self-service portal, because if your finance department wants to get a virtual machine up and running for a really urgent need, and they send a help desk ticket, and then it gets to the virtualization team, and then it gets to the person in charge, it could take a few hours to a few days to get that. We can do a self-service portal, and we can say, okay, this department has the ability to spin up and create their own VMs based on the templates and the resources that we know they typically need. We can say, okay, John in finance, if you ever need that, if you need another VM, if what you're doing isn't working, say they have a point of sale system and they keep growing, they need more and more cashiers or whatever they're selling, they can simply browse the portal and create what they need without a lot of IT interaction. Now, obviously, you have to have communicated and trained and set up and given the proper permissions because you don't want anybody just say, well, I'm going to create 5,000 VMs and see what happens. I mean, we'd want to have some control on that, but it allows the customer to kind of take care of themselves. So it's like, when you go to Home Depot and you don't want to wait in line, there's the self-service checkout, right? So this is kind of that same concept. Okay, I know what I need. I need this, this 2x4 and these screws and this drill and all that. Just go take care of it at the portal, the self-service portal, right? I need this VM, it needs this memory, it needs on this network, it needs this storage. Boom, click, 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 done. And away they go. So that's the portal. The database is the back end. Everything is stored as data, right? We live in an era where it's called big data, right? Which means there is so much data that it's so large, it's almost impossible to process or work with all of that data. And this adds to that because there's a lot of information about each VM. And when it's installed, it asks where do you want to put the database. If you don't have a database, you can do the free SQL Server Express, which will work for a basic exploration, but there are limits to the Express database. And the limits are, I think it has a maximum table size of 1 million entities. And that may sound like a really huge database, but even 15 years ago, when I was using Microsoft products, we had an Express database that I set up with some system, and about a year later, we hit that million entry mark, and the database stopped working. So I had to research, and then thankfully I was able to extract the database, create a new SQL database, not the Express version, but the actual one, and then import everything, and it worked fine. But you will, there are limits to these free options that you get from Microsoft. And they may sound, kind of obtuse, like I'll never hit that, but you possibly can. All right, so there's the database. And then the library can be described as a resource store for different types of System Center VMM features and components. And it can be shared between different sets of user roles and, of course, cloud, right? All of this can communicate with your servers in Microsoft's Azure cloud or in VMware's vCloud or Citrus's cloud. So the capabilities of this, it is really endless in that it can manage systems that are on-premise or in the cloud, and both, and seamlessly share things between them. So it really ties in all of the stuff that would be important to us. Okay. Now, installing the System Center VMM, we saw this in that video, and I'll put that video in the link of mod week 14 that we're in. So just like anything else, it has system hardware and software requirements. Here are some of the following requirements, and it needs to have that automated installation kit, the AIK, which is part of the deployment kit, the ADK that he installed, and then the .NET framework has to be there as well, which we saw that last week, right? We had to install that .NET framework 3.5 for our HMail server to work, and that's a common kind of step to install that feature before any of this other stuff will work properly. All right, then it needs a database of some sort. Okay, so here's the minimum and the recommended. These are pretty low as far as processors, a Pentium 4, 2 gigahertz, 64-bit. minimum recommended is 2.8. Not a lot of difference there. RAM 2 gigs, 4 gigs, hard drive 2 gigs, 40 gigs. Hard disk space with a local full version of SQL is 80 gigs or 150 gigs. So again, that's pretty low hanging fruit as far as resources and system requirements of today's modern computing. All right. Then once you're confident your environment meets the requirements, you can begin. So in our test environment, we'll install it on our host machine and add the roles to the same server. In a production environment, you would normally have those servers dedicated for certain roles. So you might have the management server on one, the console on another, the portal on another, and the database somewhere else, right? Just to kind of distribute the workload, right? And then these are just some of the screenshots. We saw this. These are super just informational only. Now, in one class that I taught where we were on campus, we actually installed this, and it took a long time to get it to work right, and it's just not at our level where we're just kind of getting our heads wrapped around what is Hyper-V, how do I create VMs. This is kind of like a little too much for that, but it is available. So I at least want you to see it. Okay, once it's installed, we can go through to create a new, we have to add in our host, and then we can start creating things. So first thing we do is we create our groups, our host groups. They're like containers that help you organize your hypervisor host. So this is where we can say, okay, in my group one, or my admin group, or my my finance group, or my IT group, my mail server group, however we want to group these host machines, that's where we would add in and say, okay, we'll do my Hyper-V machine, your Hyper-V machine, another Hyper-V machine, right? Those will be our Hyper-V hosts. We'll add them into a group, and then we can manage that group with policies for where our VMs will be placed, the host reservation policies, how we're going to dynamically optimize those things, what type of networking, where is the storage, what is the size of the storage, what is the type of the storage, and all those things will be included in that. And then but here's where we create and set those up. So we would say, give me a general property of a name. And then once we set that, we will go in and then add our hosts into our group. Okay, so in a really kind of compact nutshell here, this first lecture, and there's two of them today, the next one will be on backups, but this one was dealing with the System Center Virtual Machine Management product. Okay, and this again is a big piece of this puzzle, right? This image here, it kind of shows in a larger Windows environment, and it doesn't always have to be Windows, it can be other things. But we have we just looked at this corner piece, right? With the all we looked at was VMM. But there is the configuration, data protection, and operation. So like in this data protection, this is where we could install and have on our network the data loss prevention services, where we can say and set up on our entire enterprise, some of the rules that we've seen in some of our other discussions, where we can say, I want to prevent anybody from emailing this particular file or this type of file outside of our network. So I don't want somebody to take our top secret database information or a list of our employees and their social security numbers. I never want that to leave our network. Well, how do I do that? Well, you can do that in the SCDPM, the System Center Data Protection Manager. So that's a whole nother module that we can plug in here. The configuration manager. So design, configure, and deploy. So this is where we could configure, our physical environment. This is our virtual environment. This could be our actual physical install location. Then we have the management service manager, where we manage all these components, and then the operations manager, the day-to-day, our antivirus, our updates, our deployment of Office, Microsoft Office, or any other applications. So as you can see, there's all this, and then of course there's the orchestrator that makes sure all of it is working properly. All right. So any questions or comments on this lecture? Hopefully you're comfortable at least talking about or thinking about the what's going on with System Center and the virtual machine manager. All right. So I'm gonna stop right here. We're gonna take a short break, about 9 minutes. We'll come back at 9:05, and then we'll continue and we'll take a look at backups in our virtual environment. All right. And then I want to get us started on some of the information just to get things rolling a little bit with our virtual machines, because there's a couple parts that I say on the video. This will take a few minutes, and it probably takes 10 minutes, but I paused the video and then started, so it looks like it only took a minute or so. But when you do it, it might take a little bit longer. So I want to highlight those and get those going now, or so that you're not just sitting there in lab going, okay, now what do I do? Just sit there and wait, right? So I'm gonna pause the recording. All right, so the next topic that I want to spend a little bit of time on is doing a backup in a virtual environment. Now we mentioned this in a previous lecture, in the Hyper-V, or the VMware section of the course, the first 8 weeks. But this is where I want to kind of go into a little more detail, because this is an important topic that you want to be very, very concerned and well versed in, and that's, how do we do backups? And there's kind of a sense sometimes of, well, these are virtual machines. If they go sideways or something happens, I'll just spin up a new one. I'll just create a new one. I'll just start from scratch. And that's kind of our mentality in the lab environment, because this is a learning environment, right? That's what we're trying to do, is get experience in this. Well, in a production environment, if the mail server just goes, burps and dies and no longer works, it's not so easy to say, well, let's just delete it and start over. And, you have 5,000 users that go, well, what happened to all my email? Well, bad news, it's gone. We'll just have to start over. And they'll go, well, no, that's not going to work, right? Next thing you know, you're on the unemployment line going, hey, I need a new job. How do I find one? So you gotta be aware of these backups. So let's take a look at this and discuss this as we go. All right. So this is all about backing up in a virtual environment. So some of the things we want to look at here is, one, what is our backup overview? What are we talking about? And then how do we do it? So some of the methodologies, and then what are some of the considerations and best practices? And then finally, how do we implement that in our Hyper-V virtual machine environment? Okay, so the overview is and the methodologies, the easiest way to back up a virtual machine is just to make a copy of the hard drive, right? If I have a VM and I want to make sure I have a copy of it, just like if I have my computer, if I want a copy, I could just take my hard drive out, clone it, and then take the clone and set it to the side, and I have a copy, right? If anything happens to that machine, all I have to do is put that hard drive in another computer or take out the old hard drive and put in the replacement hard drive, and it's right back to where it was, right? So this is equivalent to copying a hard disk in one server block by block to another hard disk in another server. When you turn on the other server, it will have everything from the original server. Now, the downside to this method is you're talking about huge amounts of traffic. So, if we're only doing one VM that has a 40 gig hard drive, like say our VMs, that might be doable. We just say, okay, just copy those every night at 1 a.m. Right? Take the machine offline, copy the disk, put the copy in a safe location on another network share, and then start up the original, and everybody's back up and going in the morning, right? But what if those hard drives are in the several terabyte size, and you have more than just one or two of them? You say you have 40 VMs that have 2 or 3 terabytes per VM. The copy process will take longer than you have a window to do your backup in, right? So that's kind of the downside there. Now, this method also does not include any of the configuration setup for the VM, such as how much memory, the name of the VM, what network is it on, how much processing power, right? All those settings that we have to fine tune, those would also be lost if we just have a copy of the hard drive, okay? This method also doesn't give us the ability to have versioning or timestamping. So the ability to say, well, here's the backup, I want to only get this one file, it's hard to do that, right? So because the files are so large, it's not practical to have multiple copies of them. Because if each hard drive is, say, a terabyte or greater, and you want to say, okay, I need to have 10 previous versions, that means wherever you're storing these, you need 10 terabytes per VM. And again, if we have 50 of them, now you're talking about, I need 500 terabytes of storage, which is very uncommon to have that large of storage, even in today, right? Even at the cloud, I mean, that's a lot. All right. Now, another method that we can use is the export. So I don't know if you've seen this, but I'm going to log into my Guacamole. So let me just do a little demonstration here. App here. And my one-time password. All right, so if I go into my host machine here, and I open Hyper-V Machine Manager, if I wanted to, and again, I don't necessarily want to on this machine, but if I wanted to, I could click on this, and then over here, I can click export. Now, because we're using differencing disks, which are a form of a snapshot, right? Exporting of a snapshot is not recommended. If this was our our parent, we could probably get away with this. But it's as easy as just saying export, give it a location and then a name, and then hit export, and it will just make a copy of it. And you can do this on a running VM. So that's a benefit or an advantage, that we can use this method within Hyper-V. So we don't have to go to File Explorer or anything. We can just export it. And it's a fair approach as compared to copy and virtual machine storage files. In this method, administrators usually export the virtual machine from one host to another, mostly when they're facing limited physical resources. So if I'm on my Hyper-V host here, and I look at, say, my hard drive, and this is taking a while because it's trying to do something it can't do. But let me just go. If I look at my PC here, and I want to look at how much space is available, well, on this one, I have plenty of space, right? I have, 1.6 terabytes of free space. But what if I had, less than, 500 gigabytes or 50 gigabytes of space left, and I needed to create a new VM? Well, I'm not going to be able to create it on this physical server because I don't have the resources to do that. So what I may need to do is move one of these, export it to another Hyper-V host. And then I could, so I'm limited in my physical resources. I can kind of move things around. Okay, and this can be accomplished within Hyper-V Manager. Now, if you do use snapshots, you want to make sure you merge all your snapshots before you export it. So the recovery process would include importing the previously exported. So you say, we go on our one host machine and we say export, and then we go into another host machine. So we'll go over here, and on this one, we would say import. So we'll, once we have the machine, we can click here, import virtual machine, and we have to point it at the one we just exported, and then it will pull it in. Now that process is also using the network to move things around, and the files are pretty large. So the time and the storage space that you need are going to be detrimental to how well that process is going to work. Okay, so again, just like copying them, they're also exporting and importing still takes time and still needs a lot of storage space. All right. Now, a quick type of a backup for, like, say, a temporary setting change, or I want to try this before I, make it a permanent thing, is we can just use a checkpoint, right? So on our virtual environment, we can just come in here, and with the machine running, I can just click on checkpoint, give it a name, and whatever changes I have made will be shown in my system. Okay, and then once I have my checkpoint done, where it's to the point where I like it, everything works, I can incorporate that checkpoint into the actual VM, and it's that way everything's back to normal. Now, it's a point in time snapshot or a hot backup copy of the protected virtual machine, and then restoring the snapshot or checkpoint will move the VM back to the time the snapshot was taken. So if I don't like what happened, I can just say restore or delete that checkpoint, and then it goes back to where it was. So if I'm working on today's lab, I know there's a part that can go, get a little dicey, make a checkpoint, do the thing. If it doesn't work, go back to the checkpoint. Now in this class, now remember I said in the beginning when we talked about hard drives, the types and best practices, I had mentioned that we're using dynamic disks, and two, we're using differencing disks, which are not recommended for snapshots or checkpoints. So I encourage you not to use checkpoints in this class, but in your own lab environment or when you start working somewhere, you will want to be aware of that. Okay. Now, compared to the other two methods of exporting and importing and then copying the hard drive, the checkpoint is much more stable and a better way to manage the virtual machine backup and recovery. But before we do any configuration to our VM, we should take a snapshot of it. In the event that there's a problem, we could always go back to what it was previously. So it's extremely handy for when you're working on a system that, because if we are working on our actual computer and we started doing some stuff, a good technician, right, would make sure that he has a backup of the user's data files at a minimum. The system configuration would be good to have too, before you do anything. So before you just start, well, let me just see what happens. Oops. I mean, the user doesn't want to hear, oops, I lost all your files. I mean, if that's the case, your boss is going to say, oops, you don't have a job here anymore, right? So we always want to be aware of that and take action to prevent that from happening. So the same thing in our backup environment in Hyper-V. Now, when we take a snapshot, Hyper-V stops writing to the original hard disk file, creates a new differencing disk with the extension of AVHD, which is a dynamic disk in nature. Any new data will be saved in the AVHD. So this is the exact same process of a parent-child disk. So because our VMs are already a child disk, we don't want to make a clone of a clone of a clone, right? Have any of you ever seen that movie Multiplicity, right? With Michael Keaton is in it. It's been out, and he's running out of time. He can't do everything with his family and with work, and so he stumbles on someone who said, "I can make a copy of you," and he makes a clone, and then that clone runs out of time, so he makes a copy of himself, and by the time he does, it's all said and done, there's 4 different versions of him, and the last one is the clone of the clone of the clone of the clone, and all of a sudden he has like some deficiencies in his character and in his mentalities that kind of bring to the point here. We don't want to keep making clones of clones, because eventually something will break and then all of them are going to go offline. So we want to make little, in our environment, the way we're doing it, which we're doing it for speed, right? That's why we make the child and parent. You want to make sure that we try to stay away from these checkpoints. Now, when a checkpoint is created, the VM stops writing information to the disk and appears to be momentarily unavailable, but it's actually saving everything in memory. Now, recall that a differencing disk's performance is less than that of a fixed disk. Therefore, when you take a snapshot, you're going to slow down the disk performance by introducing the snapshot, which uses the technology of a differencing disk. Also, differencing disk can result in broken or corrupted chains, which can result in data loss, which is not something we want to mess with on a production server. So we go back to the first line here. One of the things that we can do is we want to use a fixed disk. In our situation, we're using differencing disk. But in a production environment, we would for sure be using fixed disk because they have better performance. And then our snapshots would be okay there. Okay. So that's our third method, right? So the first one is copying the hard drives, the VHDX files. The second is import export. The third is with our checkpoints. And then finally, the better way is to use a Windows backup program. Now, by default, Windows Server 2019 and every other version has a Windows backup feature. Now, the Windows Server backup feature has been around for quite some time and is generally well received because it's very simple to use. And this is the only option if you don't install and buy somebody else's. Okay. Now, the Windows Server backup feature cannot be used as an enterprise-wide backup. It's only on that one machine. It's not aware of all your other systems. If we want something that is aware, that goes back to our first lecture today, the System Center with that data protection module, that's where we can install enterprise versions of backup. Okay. So, and its main purpose is to provide the ability to backup of the critical data from Windows Server itself. All right. So, the volume shadow copy service, which we talked about previously, is used to make a backup of our environment. Now, volume shadow service, which operates at the block level, provides the infrastructure of Microsoft's operating system for backing up. Now, if I come over to this server, so this is my server, and if I just type backup, it says Windows Server Backup, and this is on my local machine. That's already there. It's ready to rock and roll. So I can use this to create backups of these VMs. So just like I could create a backup of this host machine, right? And this is my host machine. It's got the red background. I know that. I can also use that Windows backup to back up my individual VMs. All right. So it uses this volume shadow copy service, VSS, to copy running or open files. Because if I try to copy a system that is in use, and I do that from File Explorer, you'll get an error. It says, I'm sorry, that file's in use. Do you want to try again or skip? And if you hit try again, you'll just keep getting that error message. Whereas with VSS, it's aware of that and it can handle the backup of a running or open file. All right. Now, I want to talk just a little bit about what is this volume shadow service, copy service. And there's three parts to it. There's the writer, the requester, and then the provider. And the service sits logically in the center of the other components, and then it handles communication between them. So on my host machine, if I come in here and look at services, and you can do this on a desktop machine too. And if I sort this by name and go to the V's, you can see that the volume shadow service is running, and you probably can't read this, but it says manages and implements volume shadow copies used for backup and other purposes. If this service is stopped, shadow copies will be unavailable for backup and the backups may fail. if this service is disabled, any services that explicitly depend on it will fail to start. So this service is there, and it's set to manual. So once I set up my backup and I schedule it, then these features will kick into play. Okay. So the VSS writer, each VSS aware application. Now, I talked about APIs earlier, right? The application programming interface. Other backup systems, like I can go online and purchase backup software from, like Para Backup or, Q Backup or whatever the company's name is. And when I install it, it's going to communicate with VSS, right? So other products have to use this VSS. So it's important to understand it. So the VSS writer, it installs its own VSS writer to a computer during the initial installation. The requester is any application that needs to use data for capture can use the VSS requester, and then the provider creates and manages the shadow copies of the data on the system. So like if you look at, so this is my home computer's hard drive. So if I go into my C drive, and let me just look at a folder here. I'll go to documents, and we'll look at this CNET58 quiz 3. So if I right click on this and go to properties, and then look at the previous versions, because I have a USB hard drive on my computer that I do backups to every week, it's going to go back through here and find all these previous versions. So let's let that do its thing. And if we were on our server that we had multiple backups of, each time we do a backup, it will create a previous version up to, I think, 64 versions. If we want to go past 64 versions, we need to explicitly tell it to do that. And we need to make sure it has enough hard drive space. If you don't have enough hard drive space to get to 64 versions, it will go through and say that it needs to delete other previous versions. Okay, so on this one, you can see I only have 2 of them from a couple of years ago. So I can come in here and I could say restore this system, this file, and it overwrite whatever that PDF was. Now this file hasn't changed in almost 2 years, a little over under 2 years. That's why I don't have previous versions. Because remember, our backup only backs up files that have changed since the last time we did backup. So if I had a file that was changing all the time, I would have more previous versions. Okay, so don't let that throw you as far as that. All right, now the requester announces that it needs to create a server snapshot. So when we use a backup, it actually communicates with Hyper-V and creates a snapshot. Prior to creating the snapshot, it queries the server to determine which VSS writers are installed. Then the VSS requester instructs each writer to accomplish the task that's needed. And then after each VSS requester instructs the VSS provider to create a snapshot. And then the volume shadow copy service, aware backup solution for backing up Hyper-V, is the most preferred choice. So if you're thinking about, well, how should I back up? Should I do copy the hard drive? That's a simple way to do it. But the downside is it takes a lot of space and time. I can do the export import, but that's easy. I do it all from within Hyper-V, but that also takes a lot of time and a lot of space. I can use snapshots or checkpoints. The problem with that is I need to, be aware of that, and I may not have multiple versions. And then the last one is to use a volume shadow copy service aware backup solution. That's my best option. Now, VSS works hand in hand with Hyper-V's integration services and the VSS writer. Now, VSS aware backup solutions include Microsoft System Center Data Protection Manager. So when we install that module in System Center, it will give us an enterprise backup solution. So unlike Windows backup, which is a local solution, not an enterprise, only that machine can use it. If we go up the next level to the System Center version, then we get what we want everywhere. Okay, does that make sense? Hopefully you're able to kind of track that. All right. Now, a VSS aware backup solution can perform two types of backups: virtual machine online backups with Hyper-V's integration services, and then virtual machine save state backups without Hyper-V integration services. Okay, so within Hyper-V, if I go to a VM and if I go into the settings and I go down to the integration services, you can see that these services are automatically installed for me, right? Now, this is a Windows operating system. So Windows is able to install and handle the operating system shutdown, time sync, data exchange, heartbeat, backup. Notice that's checked. So that gives me the volume shadow copy of the integration services, and the guest services are not on. If I go to my CentOS and look at the integration services, it understands those as well. If I go to my Kali Linux, which I don't have on this one, but I do on this one, it works with that version of Debian, the Ubuntu version. It will give me the ability here, but some operating systems in Hyper-V will not be aware. It will not be able to install the integration services. When we first install our virtual machine, at first it doesn't have the integration services. It's after a restart that Hyper-V will say, well, let me inject this code, this para-virtualization, if you will, into the VM so that I, as the Hyper-V manager, can communicate easier and better with the virtual machine. So if I go into this system, so let's say Windows 10, and I want to shut this down, I can click shut down. Now this one isn't running, so I can't shut down one that's not running. But on one that's running, if I click shut down, it will do as if I'm in the VM, click on start, shut down, other, and hit OK, right? It will do that automatically for me. Whereas turn off just pulls the power out. Turn off is bad. We don't want to just rip the power out of the wall and say that turned off my computer. Bad things will happen. So we want to do a clean shutdown, and these integration services allow that. So with the Hyper-V integration services, we can do an online backup. Without integration services, we can do a save state backup. Okay, so let's describe those. So if the VM has integration services installed and the backup administrator tries to take the virtual machine backup using Hyper-V's VSS writer, which the application has to be aware of that and has to integrate with that. then the virtual machine will still be running, and a snapshot of the virtual machine and its related data will be created. And this is the highly recommended approach because it does not affect our big evaluation criteria of downtime, right? We do not want downtime unless it's absolutely impossible to avoid. Okay, so eliminating downtime, this is our friend because it will do just that. Okay, so it doesn't cause any downtime. Not all guest machines have support for the integration services. For these VMs, even if you use a VSS aware backup solution, the backup will change the state from running to save. So the backup will come into our machine and it will change the state to save, which will pause this VM, this one that's running, it will pause it. And that means it's offline. And then it'll make a copy of it. And then once the copy's done, it will start it back up. So that will have downtime. Okay. So this happens due to the unavailability of the Hyper-V integration services. Okay. Now that we have seen all the traditional and recommended backup approaches, let's take a look at some of the best practices. These considerations and best practices are somewhat generic, meaning they can be applied to other server and other data backups. All right, so let me want to check something, but we're good on time. So let's look at this. Now, one of the, probably the first thing we need to consider when we're doing or designing our backup is, where is all that backup traffic going to go? Is it going to go on our same network, right? So like if I have, and let me just pull up a topology of a system that, right, we've seen this previously in another lab, but let me just take a snip of this just so we have a picture of it. So if this is our network and I want to back up this server and this server, and let's say I want to also back up my router, and I want to save it. Let's say I put another server over here for my backups, backup server called bus. All the traffic from when I back up this server, all that traffic is going to go through here, as well as that's going to affect anything this client does, anything this client does, anything this server does, right? It's all on the same backbone of my network. So that would not be an ideal design for a backup strategy. So what we probably want to do is avoid that. So poorly designed networks can cause severe performance bottlenecks. Now, backups have a limited window of time in which they need to be performed, so the performance of the network is crucial. Now, a lot of times we will try to do our backups at night, right? You've probably heard, people say, well, let's schedule that sometime after 6 p.m. and sometime before 7 a.m. or whenever our normal work hours are. Well, in today's almost, and I say almost because it's not necessarily, but in today's almost around the clock work schedule, especially if we're outsourcing or if we have workers in different time zones, right? So when it's 5 o'clock here, or 5 o'clock in New York, it's only 2 o'clock here in California. So the time zone, I mean, we have 3 more hours so when they're 6 o'clock, their backups, well, we may still be in their systems if we're, a global company. So this old idea of saying, well, let's just back up when no one's in the system, that's a good idea. It's a great idea, but it's not super practical, because as we move around the globe and the different time zones, someone's always in the system. So that limited window becomes harder, gets smaller and smaller and smaller. So it gets, critical. So for some solutions, such as Hyper-V backups, the time needed may require that the backup is continually running. So if you have 300 VMs running on a Hyper-V failover cluster, it will not be possible to back up all machines within 1 or 2 days. It will just take too long. And if that backup traffic is on the same network as all of our other stuff, you're going to have problems. People are going to, this user over here is going to call and say, why is the network so slow? And this one's going to call and say, why is this so slow? What's wrong with our network? What are you doing? Don't you know, what's going on, and before you know it, you're in all kinds of trouble. So this will require the backups to be formed during production time. So if we can only do our backups, if we have to do our backups continuously and they're on the same network, we're going to have some major problems with our entire network, either stalling or failing completely. Okay, so how do we avoid that? Well, some of the considerations are, we need a dedicated network card for our backups, right? So on our topology, we would say, okay, we're going to get rid of this link, and let's just put this machine, this machine, this machine, if we want it backed up, we'll put it on its own separate switch, and that's the only thing here. So now this traffic is separate, right? This traffic here, this traffic here, this traffic here is not on the same network that our host machines are on. So they're going to run, they're on their own switch. This has a separate switch, and it will have better performance. These are separate network cards. So now this machine has a network card to LAN A and another network card to our backup network. Same with this one, and wherever else we want to back up. So that would be a really good idea. And this is also a good idea to segregate the backup VLAN from the client servicing VLAN. Because our backup operators should be people that have a little more networking experience, a little more computer experience, so that they're not going to, it's going to be separate from everybody else. We also need multiple network cards on both the backup server and the host machine. And if we have multiple backup cards, we could come in, and last week we talked about teaming. So what if I had 2 network cards in each of these servers dedicated to my backup? Now these would have twice the bandwidth. So if this is 10 gigabits and this is 10 gigabit, so 10 and 10, now this pipe would be 20 gigs, right? So that would really speed up. That would give me a robust backup environment. Now, there's also some considerations with the backup software that we use. The 2 main areas to consider are antivirus protection and the integration services. Okay. Our host and our virtual machines should have antivirus software installed just like any other machine on our network, right? we want to make sure everybody is protected. So let's check our Windows machine here. And Windows Defender is installed in Server 2019, just like it is installed on our Windows 10 machines. Okay. So here's our security at a glance. It says, I have virus protection. Now, did we install that on our servers? No, that's automatic. So the ability to have our client, our VMs, they're going to, if it's a Windows, Server 2019 or Server or Windows 10, Windows Defender is automatic. Now, I don't know what your impressions are of Microsoft's Windows Defender. You may have, less than stellar opinions of it, but it's better than nothing. Let me just put it that way. So if you don't have anything, Windows Defender is better than nothing. And the Windows Defender, I didn't know about this until that that pipeline in Virginia got shut down because of ransomware. But Windows Defender has ransomware protection in it. So if you're using Windows Defender, and I think you have to turn it on. I don't think it's on by default, but once you go in and turn on ransomware protection, you're protected from someone coming in and hacking your machine and encrypting everything, and then saying, if you want it back, give me a Bitcoin, which now is $40,000. So the host and the VM should have AV installed. The host should exclude the volume or directory that contains the VHDX and the configuration files. So if I were to do a scan, a virus scan, which Windows Defender will do that automatically, I should exclude the location where my VHDX and configuration files are stored. Because if these have if they have antivirus inside of this system, I don't need to scan, that's like saying, okay, inside of this box, I have antivirus. I don't need to scan the outside of the box for antivirus because it's getting scanned inside of it, right? So it's a redundancy that can cause problems. Now, there are now VM-aware antivirus software that are designed to work in a virtual environment. All right. Now, I'm going to stop right there. This is a good place to pause the recording. All right, so let me share my screen. All right, so with the Hyper-V integration services, they really do play a vital role in our management and accessibility of our virtual machines. So when possible, always install the integration services. Now, Hyper-V version 3.0 and newer, which is included in Server 2012 and beyond, and Windows 10 and beyond, it will install the integration services automatically if possible. So if it doesn't install, then that means that the virtual machine, the guest operating system, is not supported by Hyper-V. Doesn't mean it won't work, right? We already talked about that before. It doesn't mean you can't run it. It just means some of these things won't work. And the reason we want integration is it allows the virtual machine to participate in the virtual machine backup process. Any VSS-aware backup can take a virtual machine backup without putting it into that paused or saved state, and it can do a running machine, which will prevent downtime. Okay, so that's very important. Now, another thing we need to consider with our backup is storage. Where do we put these backups? And how many versions of the backups do we need? Now, a backup is different than an archive. An archive is normally a time dated copy of a system that we take off and store separate from anything else. So like a lot of companies, they will have to take at the end of their fiscal year. So most companies, their fiscal year is from July 1st until June 31st or June 30th. So on June 30th of the end of the fiscal year, IT will take a backup of their financial auditing, right? Like their accounts payable, accounts receivable, their banking, those kind of systems will get backed up, and then that backup is removed and stored, and it will say fiscal year 2020 to 2021. And they'll save that and put it offline, and that's known as an archive. A backup, on the other hand, is typically overwritten. So I may do a backup today and then save it for, 2 or 3 weeks and then rewrite over it, right? And on your storage, you may not be able to save a lot of those versions in succession. You may only have the space for 1 or 2 versions. So storage plays an extremely important part in the overall solution design and service scalability of our virtualization projects. Now, the first aspect of our virtual machine storage is how Hyper-V prevents the storage, or presents, not prevents, but presents the storage to the virtual machine. And the second important aspect is how the internal virtual machine storage is configured. All virtual machine partitions and drives, if it's Windows, should use NTFS. If it doesn't use NTFS, you may want to consider converting it from FAT32 or whatever version it is to NTFS. The virtual machine disks should not be dynamic. They should be fixed, and that's a performance reason. Okay. All the differencing in parent disks should be in the same location. They should be in the same root folder. Now, by default, ours are. Okay. It's not a good practice to take snapshots of production workloads. If you must take a snapshot, merge them to the parent disk quickly. If you leave them out there, they're differencing disks and they can get corrupted. Okay. Guest virtual machine VSS backup solutions usually do not back up a pass-through disk. Now remember, a pass-through disk is a external or a secondary hard drive installed in our host machine that can only be used by the virtual machine, right? Typically our transactional database systems will prefer, because it's the best performance, a pass-through disk. But our VSS aware backup solutions normally can't back those up. So, they're great for performance, but they're not backupable, if that's a word. Now, the native backup utility in Windows Server has long been considered a vital part of our server infrastructure, and Windows Server Backup is VSS aware backup tool. So it checks all the boxes other than it's not enterprise. Okay, but on a local, it will do the job just fine, and we can schedule these. Okay, now in the previous release of the product, if the administrator wanted to back up a virtual machine with the Windows Server backup feature, they had to back up the complete volume. So everything, it was an all or nothing backup solution. So this was because the earlier versions of the product didn't allow one to selectively back up or restore a virtual machine to or from a Hyper-V server. So previously you could back up all the volume or none of it, right? Now, since Server 2012, it's possible for administrators to selectively backup or restore a virtual machine on the same Hyper-V server. Okay. So the pre-Windows Server 2012 operating system and Windows Server backup feature didn't support backing up clustered shared volumes, but now they can do clusters as well. So Windows has quietly improved the backup features in server. In my opinion, they have quietly diminished the backup features in Windows 10. So on Windows 10, the backups it's a little more complicated to get to them. They want to do the previous versions and the mirroring as a backup solution, which is fine for files, but the system itself, it doesn't work on. Okay. Now, prior to Windows Server 2012, it was not possible for the Windows Server backup feature to back up the volumes larger than 2 terabytes, and they had to have the sector size of 512 bytes. If it's bigger than that, and the default sector size for Windows is 4 kilobytes. So you ran into problems there. In Server 2012 and beyond, now it's very much possible for administrators to perform a backup job for a volume that's larger than 2 terabytes, and you can also use the default 4 kilobyte sector size. All right. So this means this 512, that meant that the area that you back it up to had to be formatted with the 512 byte sector. Now it can use the default 4 kilobyte. All right, and it should be NTFS, all of it. All right, now I'm gonna stop right here for just a second, and I want us to get into our guacamole. So let me bring that up. And okay, I see some of you are in there already. Good. So I'm gonna go to well, let me pick somebody here. Let me see who's on. Okay. Luis Fernandez, is it okay if I jump on your server?
Yeah, that's fine.
Okay. Have you done anything on it yet?
No,
You
no,
haven't
not yet.
started? Okay, so I'm just seeing what machine you're on. You're on L5. All right. So what I want you to do is log into your server, except for Luis, you can watch me do it. And the first thing we want to do is what I'm going to do on his, I'm going to remove this Win server parent from the screen here. So I'm just going to hit delete. It doesn't delete the files, it just deletes it from the view. Okay. Now I'm going to do a new hard disk, and it's going to be a VHDX, a differencing disk, and I'm going to call this CentOS 8-I SCSI. Okay. Now I'm going to go next, and then I'm going to base that on our CentOS 8 parent disk. And then I'm going to finish that. And I'm going to do the same thing for our NFS. So this one will say differencing, and this is going to be called server 2019-NFS. NFS. Okay, and it's going to be based on our Win server parent. Okay, so it's the same stuff we've been doing all along. All right, so now I'm going to create 2 new VMs, and one of them is going to be CentOS 8-I SCSI, generation 1, going to give it 4096 megabytes memory. I'm going to connect it to the Intel network. And I'm going to use that hard drive I just created for it called CentOS iSCSI. And finish that. And I'm going to start that while we're running. Okay, now I'm going to do the same thing for my server 2019-NFS. Next, generation 1. Also give it 4096, Intel, and I'm going to use an existing hard drive, and that will be my server 2019 NFS disk that I created about a minute ago. And finish. Okay, and I'm going to start that one as well. All right, so now if I connect to this machine, this is going to start up. And what I want to do is log in here. CNET 2021 exclamation point. And what you'll want to do, Luis, in the lab, which the lab is published, you can get to the lab.
Okay.
Is I'm going to look at the wired connection, wired settings, and then the configuration. And I'm going to write down this 10.29.72.131 where it says IP version address, IP address. And then I want this hardware address as well, 0015. Okay. So that's all I need to do on this part so far. And then I'm going to come into CentOS and I'm going to power this off. Okay, that part does not take very long, but this next part does. All right. So now that this machine is off, go to the settings, click on ID controller 1, make sure hard drive is selected, and we're going to add a new hard drive. So come down to virtual disk and click new. We're going to click next, VHDX, fixed size. And I'm going to call this iSCSI -DS2, I think is what I call it. Okay. And then I'm going to make it 100 gigabytes. And then click next, and then click finish. And if you haven't gotten a cup of coffee yet this morning, you probably go wash your coffee pot, wash your coffee mug, grind some coffee beans, make some coffee, make your own creamer, and drink your cup of coffee before this will be done. This is going to take about 10 minutes, okay? So with this running, so I'm going to leave that running and I'm going to switch back over and I'm going to come into server 2019. While this guy's going, so leave your CentOS 8 SCSI, leave it creating that second disk, that iSCSI 2 disk. So I'm going to connect to this machine here. And you'll notice that performance is a little clunky right now because it's doing a lot. And maybe it won't let me connect. Cluster, no. All right, there we go. So now, oh, are you connected to this one? Someone else? Luis, are you in there too? Okay, maybe.
No, I'm not.
Okay. Let's see here. This should go. Maybe it's because I tried doing it a couple times in a row. So we'll let this start up. All right. So is everybody able to you've got your 100 gigabyte disk 2 in iSCSI, CentOS iSCSI working? You got that creating? All right. Well, we'll just leave that running. I'll come back to this in a little bit. So this is going to take a little bit of time. So it's been what, 2 or 3 minutes, and it's barely a third of the way. So that's going to take some time. So we'll monitor this. So Luis, I'll come back to this in a little bit. So don't connect to your server yet.
Yeah.
And let me go back into the backup or the lecture. Okay. So
Okay.
everybody, I want you to get to that part. That is, let me show you where we're at in the lab. So if you look at the lab, that is, so we did the differencing disks. We got the IP address. Now we're installing the hardware. We created the new drive. We made it 100 gigs. And we're right here on step number 9, waiting on step 10. So that's where we're at there. Okay. So we'll come back to that here in just a few moments. But in the meantime, I want to lecture a little bit. Okay. So in the background, make sure you're getting that disk built. So what about the retention policy and versioning? How are we going to handle that in our systems? So prior to Windows Server 2012, it's not possible for Windows Server backup feature to back up the volumes larger and 212. So now, how do we deal with the backup retention? These two concepts were not present in the previous releases of Windows Server, which used to cause administrators to script the movement of the old backup data and remove the storage to avoid the Windows Server backup feature overwriting the existing in-place backups. So you would have to do the backup, move the backup, and then have it redo it the next time. And that's how you would manually do the versioning and the retention. Now with Server 2012 and newer, the backup retention and versioning are available. So administrators can offload their burden and can keep multiple copies of the same data with different versions, as well as old and new data, that's why we do backups, is so that we can recover from or restore to a certain point in time up to a fixed amount. I mean, we can't do indefinitely because we don't have the space. Okay. So with that, on Server 2012 and 2019, backup is a feature. So if I come back into my server here, L1, and if I go into Server Manager on my host machine, and if I go to add roles and features, next, and then go features, you can see here at the bottom, I have Windows Server Backup. So I have to install that on my machine to have these features. Okay, so I'm not going to do it here, but we'll see it in the lecture. So you install that and away you go. So once that's done, we can go into the Windows Backup Administrator and tell our system to do a local backup. And we can tell it to either schedule it or do a one-time backup. And then because this is installed on a machine that has Hyper-V installed with a whole bunch of VMs here, I can tell it, I want to back up this VM. So then I click OK, select the VM I want to back up, tell it where to back it up, So I can put it on a network share here. And then I can say a folder name Windows image backup will be created inside the specific area. And how do you want to handle the access control? And I can say inherit, and this makes the backup accessible to everybody who has access to the remote shared folder. Okay. And then I'll click next, and it will say a backup of the following will be done. Okay, someone's got a chat. Yeah, your internet cut out. Okay. And then we can click on backup and it will perform our backup for us. Okay. And then on our Hyper-V system, you can see here that the status, it's still running. It is not saved. And that, I know this is running using the VSS shadow copy protocol because it doesn't take it offline. If it was saved, I know that it's not integrated. The integration tools aren't there. Okay. And then finally, it will tell me when it's done, when it's completed. And, this is relatively small, 6.72 gigabytes of data. And then I can go into the recovery wizard and it'll say, where do you want to recover this to? Where is the backup stored that you want to use for this recovery? And I'll say this server, which is my HY01 server. And I can say, when do you want to recover it from? So if there's multiple backups, you'll have multiple dates that will be bolded here. And then you just select the one that you want and you make sure you say, I want to recover it into Hyper-V and I want to use this particular name, right? Which is the original name. And then you hit recover. And when it's completed, that Hyper-V guest machine, this SAP protocol or proto, whatever it is, will be restored to where it was in the backup. Now, what was on it after the backup is gone, right? But that's the cost of doing a backup. I mean, we can't do a second by second backup, unfortunately. Okay, so that's it for the lecture material. Now let's go back to our server here. And once it's done, right? Like notice it says it's not there anymore. Just click OK. All right. And then start up CentOS. So I'm going to close that and I'm going to come back into our server. So then on your server NFS, just go ahead and hit next, accept, give it a password. And that will finish. Then we're going to, you can log into this server. Okay. Now you're not going to get to the NFS part until we're done with the iSCSI. All right. But I'm going to go ahead and log on just so it'll be ready to rock and roll. One thing we can do real quick on this is once it goes into Server Manager, I'll come back to that one. So I'm going to try to multitask as best I can. So now I'm going to start up CentOS. And what I have to do now is I have to take that disk that I just added, which is like a brand new hard drive, and I need to set it up. So what I can do here is go into activities, and to find the disk tool, just type disk and then select disks. And you should see 107 gigabyte Microsoft disk. Then you're going to click on format partition. And then here I'm going to give it the name of disk 2, or I don't remember the name I gave it. Let me see here. So here we're going to give it the name of iSCSI. That's it. So just iSCSI. And then we're going to click next and then click on format. It's going to ask us for the CNET58 password. And we're going to authenticate. And you'll see this says creating file system. And then it says completed, right? It says everything's done. And all we got to do here is close it. All right. So now on the lab, that takes us through step 17. All right. So Louis, you're going to start at step 18. So I'm going to log off your server. All right. So back on your NTFS machine or your NFS machine, you're just going to rename that, and I'll leave that part for you guys to do. All right. So let me get to the lab here. Now, I would highly recommend that you watch the video. And you can fast forward or get to the part where we start on step 19 and 18. And this is an SU-L here. I mean, I know that font looks like an I or something, but it's SU-L. And then put in the root password. And then you're just going to type these commands here. So I show the command. I tell you what to type. This one I just show it, but then I say type target CLI, and then I show you a screenshot of it so you can actually see it, because sometimes the font is better in the screenshot. And then you're going to type /backstores, and I recommend that you use tab completion. So do /BAC, hit the tab key, and CentOS will fill that in for you. And then put /blah tab space create tab space iSCSI tab /dev tab, and it'll help you fill those in correctly. Okay. Then I want you to type iSCSI space create, and then take a screenshot. Now this is my screenshot here. Yours is going to look different. Okay. Yours will have a different IQN and everything. Okay. And then you're going to type this command. And I highly recommend that you use tab completion here for the IQN part. So I typed /iSCSI /IQN dot and hit tab, and it filled in all his big ugly thing right here. And then on the end of it, put /TPGL /LUNS space create / okay. So there's a lot of complex commands here. They're simple to get right if you just use tab completion. Okay. And then that will create the iSCSI target. Then you're going to have to go back over to your Hyper-V host. So this is the first time that we are actually doing something on our host machine. So this is the machine with the red background. So over here, we're going to type iSCSI, and you'll see this iSCSI initiator will come up. Now, when you first run it, yours is going to say, do you want to start the service? Click yes. And then you'll proceed to go through the rest of the lab. All right. So I'm going to leave you to work on the lab. And if you need anything, just pop into the chat, and I will be more than available to help you. And watch the video. The video, I have that up under week 14 videos. And there's the lab video with the passcode if you need it. And watch through that. Kind of what I found is if you read the lab, watch that part of the video, do it, back up, make sure you got everything right, and then just proceed, you're not going to have any problems. Now, this lab, all we're really hoping to do at the end of today's lab, you should be able to go on your host machine file explorer, this PC, and you don't see it here, but I am going to, on this machine, I have it, everything's still running. Go to this PC and you should see, I want to see a screenshot of your local disk C, your network NFS disk, and your iSCSI disk. When you set up CentOS, you'll have iSCSI. When you do your server 2019-NFS, you'll have your shared NFS, and away you go. Okay, so really there's you're going to send me a screenshot of iSCSI, then you're going to send me a screenshot of iSCSI and shared VMs, and that is on our local, your server that you log into. Like first, you know, like me, it's R4 and L1. Now my L1, I don't see it because my those virtual machines are not running. So these, obviously those machines that you just created, they have to be running for them to work. Okay, so make sure if you don't see them. And those are the only two VMs we're working with. We're not doing anything with DHCP or Active Directory or Windows 10. We're just doing CentOS iSCSI and Server 2019 NFS. All right. Any questions on any of that? No? All right. So just hit me up in chat. And if you have any questions or comments, I'll be more than happy to help you. And yeah, it does sound good, doesn't it? All right. I'll see you in a little bit.